Let's get started with Unit 8, Day 1 notes. List all the transformations for the following quadratic functions. You see this x minus 2 that's inside the parentheses? Anything that's inside the parentheses with x here, at least that's being subtracted or added to it, that's going to be a left or right transformation about the origin, and it's opposite what you think it would be. So you might be tempted, oh, we're going left 2 here, and in fact, you're actually going right 2. And if you ever want to see why, ask me during class. I'd be happy to show you why. Here, you see that negative in front of the parentheses? I'm going to abbreviate because this is a lot. That's a reflection over the x-axis. Here inside the parentheses, that plus 2 means our graph is going to shift left 2. And that minus 1 to the right of the parentheses mean our graph is also going to go, I'm running out of space here, it's going to go down 1. Here, that 2 right in front of the x squared, that is a vertical stretch of 2. And here, that 1/2 that's in front of the x squared, that's going to be a vertical compression. That minus 3 that is to the right of the x squared, not in parentheses, means we will also shift down 3. Now here, now predict how the following graphs will transform from the parent function x cubed. So up here, these were all quadratic functions. Down here, these are all cubic functions, and there will be no change. Everything is the same. And if you want to take a moment, pause the video to write that information down, feel free, because I'm moving on. All right. Graph the following without a calculator. Without a calculator, I should probably have circled the without part. Then write the domain and range in interval notation. All right, so the parent function of a quadratic, I'm sorry, not a quadratic, but a cubic function is as follows. This is the parent table. I would just memorize this. But I suppose the most important thing to memorize would be -2, -1, 0, 1, 2. Because even if you didn't remember the y values, you can always plug them in into the function. If you plugged in -2 for x cubed and then cubed it, you get -8, because -2 times -2 times -2 is -8, and so on. You can do that for all of them. Okay, now let's start plotting these dots. And then let's connect. It's going to continue forever. If you'll notice, we're going down and up forever, and this will continue expanding left and right forever. So what that means is our domain and our range is -infinity, +infinity. If it is a cubic function, it will always be -infinity, +infinity. Now here is where they want us to list the parent table again, but we already did that. I'm not going to duplicate my efforts here. And here we're going to build a transformation table. Learning how to use a transformation table makes graphing incredibly simple when there are transformations to a particular function. So here in parentheses, x minus 2, that means we are going right 2. Our graph is going to shift to the right 2 from the origin. So here in the horizontal column, right at the top, I'm going to do x plus 2. We're going right 2. There are no transformations that are occurring to y here. So here, just put y. Now what I'm going to do is I'm going to take all these x values here, just the x values, and substitute them for x and then add 2 to them. So if I took -2 and added 2, that's 0. Now if I take -2, I'm sorry, -1 and plugged it in for x, -1 plus 2 is 1. Now take 0 and plug it in for x. 0 plus 2 is 2. Take 1, plug it in for x. 1 plus 2 is 3. And then take 2 and plug it in for x. 2 plus 2 is 4. Now we're going to take these y values, substitute them for y, and they're not going to change because we're not adding or subtracting or multiplying anything to it. So here, -8 still -8. -1 still -1. 0 still 0, 1 still 1, 8 is still 8. And now we're going to plot our new set of coordinates. And once again, domain and range, negative infinity to positive infinity. And you see how this graph here, it just shifted right too. See? Look at that. All right, here we're going to have a stretch of 2. That's a stretch of 2. Now, if you will notice, there are no parentheses here. No parentheses, so that means there is no change in x. That number that is in the very front in our transformation table, we're going to multiply to y. So 2 times y. And now let's take the x values of our parent table, all these x values, substitute them here for x. So there's going to be no change. If we plug them in here, it's going to stay the same. Now we're going to take our y values from the parent table, substitute them here, and you're going to multiply every single one of them by 2. So if I took negative 8 and substituted it for y, 2 times negative 8 is negative 16. 2 times negative 1 is negative 2. 2 times 0 is 0. 2 times 1 is 2. 2 times 8 is 16. And now let's plot our new sets of ordered pairs. Negative 2 and negative 16 is going to be somewhere down here. Negative 1, negative 2. There you are. 0 is 0. 1, 2, and then 2, 16, so we're way up there. And then here, domain and range, still all real numbers. Let's go ahead and move over to the next side. All right, looking at example D. I'm not going to worry about the parent table because look, I have it right here. How convenient. No parentheses here. No parentheses. X is not going to be changed in our transformation table. No changes occurring to X. Now to the right of X cubed is plus 2. So over here in the transformation table in the Y column, let's put Y plus 2. All right, now we're going to take our X values of the parent table, plug them here into X, and there will be no change. They're going to stay the same. And now we're going to take all these Y values, substitute them for Y, and then add 2. So negative 8 plus 2 is negative 6. Negative 1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 8 plus 2 is 10. See that? Easy stuff. Now let's plot. Now graph. Domain and range. This is a cubic function, so negative infinity, positive infinity. Okay, now example E, where we have quite a bit going on with this and a lot of transformations. The number inside the parentheses with the x plus 2. That means our graph is going to shift left 2. So over here in the x column, let's do x minus 2. Every other transformation, the reflection and the vertical shift down 1, all that occurs to y. So the negative in front of parentheses here, let's do negative in front of y, and then minus 1 to the right. Okay, so let's take these x values of the parent table, substitute them here for x, and then subtract 2 from every one. So negative 2 minus 2 is negative 4. Negative 2 minus 1 is negative 3. 0 minus 2 is negative 2. All right, now we're going to take all the y values, substitute them for y, multiply it by a negative, and then subtract 1. So if we take negative 8 and plug it in here, A negative times -8 is +8, and 8 minus 1 is 7. Take -1 and plug it in here. A negative times -1 is +1, and 1 minus 1 is 0. Let's take a 0 and plug it in here. Well, 0 minus 1 is -1. Take +1 and plug it in here. Negative times 1 is -1, and -1 minus 1 is -2. Let's take +8 and plug it in. -1 times 8 is -8, and -8 minus 1 is -9. And now you're going to plot all of these new ordered pairs. Yeah, this one's flipped. See that? That's what a reflection over the x-axis is going to look like to your cubic functions. This, same. And then example F. No parentheses here, so no change in x. So let's put in our horizontal transformation column, let's just put x. Everything else goes to y. Now listen, you could do 1/2 times y. I could write that down, but I don't like doing that. Here's what I'm going to do. And I'm going to write it over here to the side because I don't have enough room. Instead of 1/2 times y, I'm going to do y divided by 2. It's the same thing. And then let's do +3. So any fractions that you have, I would just write it in this format. All right, let's do it. No change in x, no change in x here. So all of our x values, when we plug them in, they're going to stay the same. Okay, now, -8, if I plug that in here for y, we have -8 divided by 2. And -8 divided by 2 is -4, and -4 plus 3 is -1. Now here, -1, plug it in there. -1 over 2 plus 3. What? I don't want to have to add and subtract all that stuff. So I'm not even going to worry about this particular row. I'll have enough plots without plotting that one to have an idea what this graph is going to look like. Now let's take 0 and plug it in here. 0 divided by 2 is just 0, and 0 plus 3 is 3. If we took 1 and plugged it in for y, 1 over 2 is 1 over 2, and 1 over 2 plus 3, I'm not going to worry about that. I'm not going to plot fractions. At some point, we will have to, but not today. And when we get to that point, I'll show you what to do. Now take 2, plug it in there. 2 over 2 is 1, and 1 plus 3 is 4. And now let's plot the points that we can and graph. And okay. Oh yeah, here, domain and range. You know what? I'm realizing I did something wrong. What did I do? Hang on, give me 1 second. I'm gonna find it. Oh, here. I plugged in the wrong number. I accidentally plugged in 2 for y instead of, I thought the graph was looking a little weird. Here, we need to plug in 8 for y. 8 divided by 2 is 4, and 4 plus 2 is 3. So this should be 7. So right, 2 up. 2. That's where it should be. So let me get a different colored pen here. It should look like that. There you go. Apologies. Okay, let's now take a look at the guided practice. For each of the following, describe the transformations. Here, that's a vertical, that's a reflection over the x-axis. Here, that's a compression of 2/3. Here, up 4. Here, we're going right 5. Here, down 7. Here, we have a stretch of 2. and here we're going left 9. And now to wrap things up, let's graph this final function here. Inside the parentheses, I see x minus 1. So in our horizontal transformation table, we're going to write x plus 1 at the top because we're going right 1 here. Here, this means we're going up 3. So in the vertical column, let's do y plus 3. So I don't need this because this is my parent table. And now I'm going to take these x values, plug them in here for x, and I'm going to cover up this column because I don't need it to save me some confusion. I'm going to take this column, plug them in here for x, and then add 1 to every single one of these numbers. So -2 plus 1 is -1. -1 plus 1 is 0. Plugged in all those other numbers, that would be the results. And now I'm going to take these y values, substitute them here for y, and add 3 to every single one. So -8 plus 3 is -5. -1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. And 8 plus 3 is 11. You now plot and graph. Have a good day, everybody.